for it. Get in here. Attendance, there we go. Well, Cody, I know where Cody is. Red, Corey. I keep trying to make you not here. You know, Freudian slip of the hand. I don't know. I know where Jordan is. Austin here. There's Austin right in front of me, and Tyler. Okay. First off, lab write-up questions. I've been catching up from being gone for 2 days and only having a little access to email. So to be honest, I haven't gotten in and looked at anything yet. I don't. So if you've written me something there, I haven't seen it yet. Overall questions? Any questions on that? Okay. Yeah, I'm trying to get you to make the connections we've been talking about. This is that theory and hands-on practice to explain this to me part. Okay, so we're kind of wrapping up that discussion right now. Okay, well, if none on that, we'll start looking at your next lab session.
I don't remember what from my lab pickup.
As promised, we're going to start doing PSTN trunks. And here we go, from beginning, there we go. Of course, the major difference than this and our other labs is we're stepping outside that single SIP world. You know, we've had boundaries around our world that basically were one system. All the devices were local to that system, and they were all connected with LAN technology. Tell me a few differences between, from the point of view of something communicating on IP, tell me a few differences between being on a LAN and being somewhere across a wide area. And there are several differences.
Well, for one thing, on a LAN, you're not generally stuck behind that. You don't really have a firewall between you and where you're going.
Right. Don't have to deal with a firewall.
Although I see situations where you might.
Okay. What else? Talk to me about bandwidth. LANs are, define what a LAN accomplishes. What does a LAN do? In the big scheme of things, who does it connect and within what radius? Right. A LAN by definition is a fairly short-range thing. You know, we're dealing with cabling that supports signaling out to 300-ish feet, 330 feet, 329.82, if you want to put the decimal places in there. We stretch that a little bit when we start dealing with VLANs. You know, I can do VLAN bridges and things. But we're still talking about a single broadcast domain. Okay? Typically, LAN cabling is high speed, so I have lots of bandwidth, particularly relative to voice. What's the bandwidth for what's the bandwidth for PCM audio? 64 kilobits, the way we've been talking about. Now, I know that's a synchronous thing, that's that PSTN stuff, but remember I said that you take that coding scheme, put a wrapper around it that allows it to be used on a packet network, and you have G.711. We'll compare protocols a little later, but what you're going to find is even then you're looking at less than 100 kilobits. 100 kilobits on most LAN connections in the enterprise now are at least 100 megabits, probably 100 megabits full duplex. Pretty sizable number of them now supporting a gigabit. 100 kilobits is nothing on that. So, in other words, from the point of view of that application, we basically have unlimited bandwidth. What we theoretically run into is jitter and delay because of other traffic, and we will look at that. But when you have 100 megabits, I can move an awful lot of traffic pretty fast across the network. So we really don't have to do that much on a LAN. Now, what do WANs connect?
A whole bunch of other
LANs that are physically separate, right? Okay. Now, can you have a router separating two LANs? Yeah. Actually, our lab environment at the main site has precisely that, and you saw that in this last piece. What LAN, data or voice, did your soft phones live on? Ooh, he's asking a specific question. Well, where are the VMs? Where do they live?
live on a separate LAN than the smartphone does.
Right, they live on the data VLAN, and that's something we have to deal with. We have the choice of either putting our PCs on the voice VLAN, which sort of defeats the purpose of having a voice VLAN, or putting soft phones on the data VLAN. That problem doesn't go away. Yeah. The hard phone is on the voice VLAN. So we're crossing a router there already, but again, we've got a router, two LAN connections. That's not going to introduce a lot of latency. When we start introducing WAN protocols, even today, we have a lot of wide bandwidth solutions available for WANs, but an awful lot of the places you're going to work aren't going to be using them yet. They're going to be using the infrastructure that's in place, which is what we've been talking about, T1. Now they're using it as a data network, which we haven't talked about yet. We will very quickly. But I don't have that unlimited bandwidth to look at the world. Okay, that's one thing. Second thing is we have to deal with signaling differences, right? We've been in a SIP-only world. Okay, with this lab, we're going to connect to the PSTN using those protocols we've been talking about. We're going to look at FXO, FXS analog signaling. SIP doesn't understand that. Doesn't know what to do with it. We're going to look at PRI. SIP doesn't understand PRI. It knows that there are such things, but SIP doesn't understand it. So in other words, what we're doing is backing into using a gateway function. And if you remember from earlier classes, gateways actually take traffic and they decode it way up the OSI stack. In this case, it's going to go all the way up to layer 7 and then be re-encoded. Okay. So that's the function we're looking at. I'm not going to throw all of that at you at once. What we're going to look at first, this is what we've been in, this is what I've been talking about. What we're going to do is start looking at, and by the way, you'll have a new picture on your lab now. The world got bigger. We're going to create two different sets of trunks, and we're going to do them one at a time. Creating trunks is a different process in SIP, and if you think through, that kind of makes sense. When I create users, when this was my world, I created a user and specifically created an identity at whatever domain is controlling this, right? We even used that for the username. When you looked at your SIP captures, you had, I forget the numbers you used, 111 at 10.10.10.1. Okay? We don't use domain names in here because I'm trying to make a real clear point on stuff. Besides, DNS is just one more thing to break in a lab. I don't love that. But we created identities. And I'm living in a packet world, so every packet I send has all of the addressing necessary to get wherever it needs to go. Okay? We don't have that when we move to this world. Okay? So when we create trunks, we're actually going to go through 3 discrete steps to do this, realizing that what we have to accomplish is, 1, keeping older protocols, the PSTN protocols, happy. What do I mean by happy? PSTN protocols were designed in a circuit-switched world, which means for every interface, the PSTN assumes there is precisely and only one other endpoint, the one on the other end of that trunk. But you can go through lots of switches and say, yes, but we build the path one step at a time. Okay? I know we have common channel signaling. We still build the actual voice path one connection at a time. Okay. So to make that happen, we have to make sure that that signaling protocol, whatever it is working. We're going to look specifically at two of them in here. There, as we've talked about before, there are several of them out there. The two we're looking at are the most common ones you'll see. After we get the interface done, that's great. But all we've done is just make the physical layer happy. We haven't moved anything. Okay. At that point, we have two worlds. We have SIP on one side and PSTN on the other, but we haven't shown them, we haven't related them to each other at all. So the second thing we're going to do is create a trunk account. Now, this gets confusing. You are not creating a user. You are creating a trunk account that's a handle for SIP. I'm avoiding using the word identity. That's sort of how it functions. It gives SIP a way to attach to that trunk, to know that it's there, to know how to use it. Okay? And we define things in that interface that let SIP know this is an analog or this is a PRI interface, and here's how SIP needs to use it. Okay? The third step in this, let me catch my notes up here. So we're going to configure the physical trunk interfaces, SFXO or PRI. We're going to configure the SIP trunk account, which is that handle to let SIP deal with this. And we're going to configure a trunk group. What's the trunk group? Only being a little bit of a smart aleck, it's a group of trunks. Now, what I mean by that, trunk, you can have more than one physical interface that handle calls of a particular type. When we were doing dial planning, I got you thinking in terms of what kinds of calls do you make? And what sort of things were we saying when we talked about kinds of calls? When we were talking about templates, what were we talking about? 911 was one, but in general, what we were talking about was calls that were dealt with similarly from a routing point of view. All of the, our extension calls are all internal. Our calls out to the LEC were another type. Our calls to long distance were another type. That's where the trunk group comes in. We configure accept and reject rules here. This is the group. There's some other things we can do. That'll do for today. We have the bridge between SIP and the PSTN protocols here, and then this is the physical interface. So the order you do things is you configure the interface, do everything to make that interface happy, and the other end. You configure the bridge, if you will, and I'm using that term loosely. It's not exactly a bridge, it's an interpreter, if you will, between whatever protocol you have on the PSTN side and SIP, and then we take that trunk account and we add it to the trunk group, which is where we tie that interface and that behavior in SIP to a particular set of routing that the switchboard process can use. Okay? And we're going to do this twice. First off, we'll do it with analog trunks. We're going to use the FXO port. What's FXO stand for? I know it's Monday. I know it's warm. Foreign Exchange Office. What's office? What's the significance of saying office? Maybe quiz time. What? I'm sorry?
It has to do with the CO. The CO is the central one.
Okay.
And that's the switch.
Okay. You are. If we're talking about FXS and FXO, let's say we're talking about a user's telephone, a regular old analog telephone like your parents or grandparents had, and a central office. Which end is FXS and which end is FXO? No, that's the confusing piece. Remember, we're talking about a signaling pair. Okay, this is symmetrical signaling. What does symmetrical mean? It means both ends do different things, but they're mirror image, so it's balanced. FXS is connected to a station. So in the example of a user's subscriber's phone connected to a central office, that phone is connected to the switch. The switch sees that port as a station on the far end. It's the PSTN term for an endpoint. So FXS ports connect to a phone. What does an FXS port, since it's on the switch, have to do? And that signaling we talked about, that loop start signaling. Two things. Has to supply ring voltage.
And then turn around and signal where the destination.
That's actually a completely different trunk. On that, you're right. The switch has to do that, but on this one interface, I have a switch, I have a telephone. If I have a call going to that phone, we've identified I have to provide ring voltage to that phone so that it rings. What else does that switch interface have to do? Has to provide current under what conditions? Yeah. When do I provide current? You're absolutely right. When the phone goes off the hook. Okay? So in other words, when you pick up the phone, in other words, when you're going to use the phone, you don't pick up the phone usually except for two reasons. It's ringing. We've covered that one. Why else do you pick up the phone? Because you're going to make a call. So when you pick up the phone, the switch supplies current, is actually where I was going with that. The switch detects that current draw and sends you dial tone. So the next thing it expects you to do is what? Dial, which does what from a network point of view? It's network addressing. You're going to tell me where you want this call to go. Okay? Now, this is all, 1920s kind of stuff. But it accomplishes what we need to do. FXS and FXO are balanced in that. Okay, we've talked about what FXS, the switch end of that, needs to do. What's on the phone end? What kind of interface? FXO, right. Remember we said FXS and FXO have to be connected in pairs. You can't have FXS to FXS because both ends are trying to supply digits, both ends are trying to receive ring voltage, both, all that stuff. And we can't have I actually outlined FXO, but you have both ends trying to do the same thing. They're not complementary. So these are always implemented FXO on one end, FXS on the other. What you said is I admit, confusing. The FXS is attached to a station. It isn't the station end from a signaling point of view. Similarly, the phone end of that is attached to an office, and it provides the complementary set of functions to an office. So what we'll do in this is we're going to go in first, and we're just going to follow those three steps. We're going to configure the physical trunk interfaces. Quite honestly, in FXS and FXO, there's just not a whale of a lot to configuring this. Basically, you're going to identify which interface you're going to use. On the 7100, there are two interfaces built in. Those are the ones you'll use. They are FXO 0/1 and 0/2. You do have FXS interfaces. We're not using them. Okay. What would I plug into an FXS interface on the 7100? When would I use that?
When you've got your own, one of those internal network setups that then connects to the
Could be. What's a simpler application for an FXS port? What does FXS connect to? What's S? Station. And station in PSTN parlance is what? A telephone. I can plug an analog telephone in there and put calls to it. Okay. So what you're going to do is go in, basically you're going to identify the particular interface that you're going to use for a particular trunk. You do this for each of the interfaces individually. We're going to have a description that you use for that. It's just that. It's a name. It's a descriptive name. Good practice. Write this down in things that will always pay off for you. Good practice is to always write a description of an interface in your configuration. Whoever comes behind you will be really happy with you. And who knows, that person may end up being your boss sometime. So it pays to be nice. Seriously. Document what you do, and part of that is putting descriptions in. What kind of description? These are PSTN connections. They are point-to-point connections. Describe, I know where I am. Describe what's on the other end of that link. So in this case, we're going to say something like analog LEC connection, or LEC connection number 1, LEC connection number 2, something to that effect. I know where I am. The LEC is what's on the other end. Okay. So we get the physical interfaces configured. Next thing is we're going to configure the SIP trunk account. We will basically, we're going to tell SIP what kind of interface this is. What does that do? Tell SIP what it has to do to translate the information coming from this interface into SIP. Tells it how it needs to handle that. And then we're going to associate, no I did, I thought I left a C out of there, associate an interface with SIP. In other words, these interfaces that we created, now we're going to associate them with a trunk account. Okay? That forms that bridge between the signaling on that physical interface and the SIP use of that interface. Okay? Last thing we're going to do is to configure the trunk group. This is and it's important to understand, this is a separate thing you do. It's a separate object you create. So you can create a trunk group. You're going to do several things to configure. You're going to give it a name. You're going to give it a description. We're going to associate trunk accounts with it. Now, I show 2 trunks in this connection. They're going to be FXO, I'll get it out of my mouth in a second. FXO 0/1 and FXO 0/2. 2 separate interfaces. I will have 2 separate accounts. I want the same traffic going to those interfaces, right? They both go to my LEC. It doesn't make any sense to say only some numbers can go over this trunk to the LEC and only some other numbers go over the other. We're going to route the same calls to them. Rather than program a trunk for each one of those interfaces, I'm going to take those SIP trunk accounts and put them in a group that has all of the accept rules with it. We're going to share one set of programming between multiple physical interfaces, and that's actually what a trunk group does. Okay? So we'll associate the trunk accounts with that. At that point, we have a working, let me catch myself up here. We have a working trunk, assuming you've done everything correct. Well, almost. We need to define accept rules. What's an accept rule do? This is not a call template. What's an accept rule do? This is what we did in dial planning that we really haven't done in the lab as yet. We sort of did. When we create users, we've been creating users that actually were phone numbers at a domain. Doing that, you create an accept rule for calls to a particular phone number, but really what you're doing is sending calls to a particular user. Trunks aren't users. They're ways to get to users. Okay? So what I'm going to do here is I'm going to define rules using that syntax we looked at for North American Numbering Plan, or just for dial planning. We're going to define rules that accept particular numbers, particular number patterns on that trunk interface, that trunk group interface. Yes, sir?
Can you not just accept everything through the trunk and then
You can.
everything on the user end decide what anything goes through once it gets through the trunk?
Yes, I can accept everything on a trunk. No, I can't put everything on the end for two reasons. One, PSTN doesn't do that. And this is one of the things where you've learned things out of order. You guys are used to packet and IP and routed networks. Okay? Let's say we turn basics. What's the first rule of turning on firewall security? You have a trusted side and an untrusted side. Traffic coming from the untrusted side to the trusted side by default is usually discarded. I don't let traffic in. And that's what you're describing. What you're saying is I would send traffic here and let this end discarded. The PSTN doesn't understand that because it's a very hierarchical system, and both ends of that connection historically were under the control of the telephone company. So instead of using my network, giving away my resources to let calls across it, and then saying no, I control what goes into the trunk, and it's exactly backwards from the way you're used to thinking about network. Doesn't make it wrong. It's just you got to invert your thinking a little bit. Okay. In a SIP world, SIP is an IP application. So can you do that? Absolutely, you can. I can go in, and in my firewall, I can say SIP traffic from Jimmy Figgins is somebody I do not want to talk to, so never let anything from that domain through. Okay. I can do that sort of thing, but normally I wouldn't. Okay. From a routing point of view, what you're doing is realizing that you don't want to tie up resources for calls you can't deliver. Okay. Good question. So I'm going to define accept rules. This is exactly like the paper exercises you did before. Where do I want this particular call type to go? I'm going to define number complete templates in my call plan, and I'm going to associate template accept rules for where I want calls of a particular type to go. For the LEC, what kind of in North America, for what kind of patterns do I want to send to the LEC?
Everything but long distance and internal.
Okay. So how would I do that?
With the let's go outside number, you got to have that there, or the whole 7 digits.
You're on the right track. Okay. Remember that the process that actually makes these decisions is called the switchboard process. Okay. We have our local phones down here, 111. I just got back from Orlando, and all of a sudden those look like Mickey Mouse ears. 222, and then I have my connection out to the PSTN. Traditionally, I would have an accept rule on this interface for 111 and an accept rule on this interface for 222. In SIP, we effectively do that because what you're saying is send me to user 111, and I'm going to send that to whatever IP address is configured. To send stuff out here, when we were looking at dial planning, what accept rule would I use for everything that isn't defined somewhere else? In XX, XXXX, tell me in words what that defines. What pattern does that match? N is 2 through 9. X is 0 through 9. Yeah. So basically in North America, this is an exchange. First 3 digits you dial on the phone number. This is the subscriber, the last 4 digits. Okay. What if I didn't even want to do that? What if I just wanted to say, unless I know exactly where it goes, send it here? In other words, I wanted to create a default gateway. $sign. What does $sign match?
The entire universe.
Okay, let me. You're absolutely right. Let me say it another way. $ matches any number of any digits. Okay, so in other words, this will match anything I dial. How do we decide if the switchboard has multiple matches for the numbers I dial? How does it decide between them? And the best match is? yeah, define best without using the word best, right?
The more digits and the more similarity.
The more exact the match, the better it is. So in other words, if I have a match for this that is 3, 3, 3, both of these match. Which one's the best match? This is. Actually, I'm sorry, that's a bad example. I got ahead of myself. If I dial 111, does that match 111? Why does it end up here? Because this is a better match. This matches exactly 111. There is no ambiguity. This is a match, but not a great match. Okay? So with that in mind, what we can do on this is we can actually put $ right here. Now, we're not going to have you do that in this lab. Okay? But you could put $ right here, and basically anything that isn't defined on another interface is going to be sent out here. Okay? We're going to do it a different way. Like I said, there is rarely one way to do things in this world, in our particular world. What we're going to do is match a steering digit. Did we use steering digit or not? We switched back and forth. Yeah, we did. That's right. We're going to match a steering. We went back and forth on that one, and I've slept since then. We're going to match a steering digit. Remember what a steering digit is? It's one that's used in the dial plan locally and then removed before you send a call further out. Okay. So we're going to put a steering digit in XX, XXXX. So what you're looking for is for people to dial, users to dial that steering digit, say it's 8, followed by a single digit 2 through 8, followed by any 6 digits. And that will route to the PSTN. When we send it out the interface, we'll delete the 8. PSTN gets exchange in 4 digits. And it does its own routing thing. Now, here's the piece that you're going to have to pay attention to a little carefully. Since I need you to be able to test this in a lab where you can't actually see the physical phones or hear bells, here's what we're going to do. We'll have you build this network connection. The LEC is already programmed. Okay? You're not responsible for the LEC. You're going to create, we won't use the hard phone on this lab. You're going to create users for your soft phones that are 4-digit dialing. We're going to test that. You're going to dial directly from here to here. One of the instructions is to notice what the caller ID on your soft phone says. Okay, have you been noticing that when you made a call? What do you see? Whatever we put in first name and last name and the extension number, right? Okay. To test this trunk, what we're going to do is have you dial from soft phone 1 to soft phone. We're going to have you dial it as if it's a LEC number. So you're going to dial the steering digit, the prefix for your site, and the 4 digits of soft phone 2. What will happen, if you've configured things correctly, is the call will route out one analog trunk. Steering digit will be stripped. I'll send 7 digits to the PSTN. It will route on the 7 digits. One trunk's off hook. Since they both share programming, it'll route the call back in the other trunk. So you'll get a call between these 2 phones, but it goes out to the PSTN and back. It's normally a bad thing to do this. It's called tromboning. You know, you've seen people do that, so I'm a trombone player. I can make fun of them. For this lab, it demonstrates what we need to see, which is how do the calls route. Okay, we're going to dig a little deeper into it than that even. If we need to, we'll define reject rules. When do we use reject rules? It's a fairly limited situation.
We want to limit a user to make a certain type of call.
Absolutely right. Let me rephrase it in terms of dial planning. I use a reject rule to prevent a call from going through an interface that would otherwise be allowed to pass. So from a functional point of view, you're right. I'm going to stop calls that are allowed to go through that interface. Okay.
It's essentially telling users they cannot dial 1-900.
And the reason I made the differentiation in what you said, this isn't user-based. This is strictly on the interface. So if I put a reject rule here, it doesn't matter who dials it, it won't go through that interface. How did we manage controlling who can make long-distance calls, for example? How did we do that earlier? Classes of service. Classes of service is how I can say these users can do one thing, these users do another thing. If I put the reject here, it doesn't matter what class of service you're in, the interface is going to reject it, even if your user is allowed to make 900 calls, for example. Okay. You okay on this?
So basically, that would be a way of just, if you don't want anyone to do it, period,
Right.
you do the reject rule.
If it's never, ever, ever okay, I'm going to put a reject on this interface because it'll stop it no matter the source. If it's okay for some people, I'm going to put those people in a class of service group and say, okay, these users can make that call, nobody else can. And if you look closely at the executive users, that's basically what it is. They're allowed any type of call, and as you step down to the other sets of users, there are two other default groups. They lose privileges. Okay? Okay. When we switch to the PRI version of this, we still have the same three basic steps. Okay? We want trunk connections. Whoops, I put the wrong picture on that. It's supposed to be the PRI picture. You guys are getting the new slides. Sorry about that. This should be the PRI connection. What I'm going to do is configure the physical interface. The physical interface is the T1 interface. Okay? So I'm going to configure, first off, system timing. Remember I said that this unit was picky on timing? This will not work. Sounds like something's blowing up over there. Yeah. This will not work if you don't configure timing on this system. And basically what you're going to do, it seems backwards to me because the system clock in this device is much more accurate than the one we're locking it to. But we're going to tell the 7100 to look at the connection to the PSTN for timing. Remember that timing connection we said where we have one clock that's free running and one that we lock to? The PSTN is going to be that free running reference clock. Your NetVanta is going to look to that interface for timing, and that's how the whole system will then generate any timing signals that it needs to do. After we do system timing, that, by the way, is a system level configuration. You do that for the entire box. Basically, you're going to say, look here first. You actually have an option to say, look at another interface if the first one fails. We're not going to worry about that.
So for the lab, we're doing system timing to the PSTN, but is it possible otherwise to just use the 7100?
You can run it internally. It will not bring a T1 up unless you specify system timing. I've never tried hooking two of them back to back with that kind of timing reference. I'll give it a try. Problem is, if you set them both up to look at network, they chase each other, and so the timing's never locked. Yeah. Past what we're doing in here. Okay, once we get that done, we're going to set the physical parameters and the framing parameters. So we're going to set all this stuff we've been talking about. We're going to specify that for the interface. What kind of framing are we using? What kind of line coding are we using? How fast are we going to run the individual DSOs, 56 or 64K, all of that sort of stuff. After we get the T1 interface up, and you will see it come up, Only then do we configure the PRI interface. It's a completely separate piece. It is part of the interface, but you configure it as a separate piece. Okay, we'll make sure that comes up. Once we have it, this is exactly, once we have that interface configured, then the rest of this is pretty much the same as our analog trunk. I'm going to create a trunk account. In this case, instead of saying it's an analog, I'm going to say it's a PRI. Why? Because this is the bridge between that PSTN signaling and SIP signaling. Well, I've got to tell it what kind of signaling is being used on the PSTN. So I'll create a trunk account there. We're going to configure, should say trunk parameters. I'll fix that one. And I'll associate the PRI interface. Why the PRI interface and not just the T1? Because the PRI interface is what's actually carrying my traffic and my signaling. So we're going to associate the PRI interface with SIP through that user account or trunk account. Then we're going to configure the trunk group. We're actually going to use the same trunk group. And we'll associate the trunk account with it. We'll define our accept rules. Again, nothing changes there. And we'll define our reject rules. Nothing changes there. So really the only differences, the major differences are in that first piece, configuring the physical interface. A little bit of difference in the second one, simply because I've got to tell it what kind of signaling. But other than that, it's pretty much the same. The last one is the same. And in fact, it's possible to put PRI trunks and analog trunks in the same trunk group. How would that work? Because I'm using the same set of routing, same switchboard commands, accept rules and reject rules. This is where my signaling is handled. I've got separate interface. I've got separate trunk accounts for those interfaces. So I can actually mix interface types in that trunk group. Okay. The lab itself is actually fairly straightforward. There's a lot of new material for you. The kind of thinking we were talking about. You know, this is not a packet interface. What gets confusing is it is not packet out here. Once it hits here, it is converted to SIP, which means it's converted to a packet format to be delivered to your endpoints. Why convert it to SIP? Because your endpoints are SIP. Your endpoints have no idea that the PSTN exists. They only know about the SIP environment. I'm sorry?
Especially if the sending of hunters happens in mode.
Say it again, I'm sorry.
So if the sending the server is acting like a modem in that instance?
Not a modem. It's acting like a gateway. Application gateway. Remember in your OSI model you have something, a gateway is something that translates the entire stack. So we're going to take PSTN traffic, take it all the way up to what we would call the application layer. That doesn't really apply to the PSTN. It does apply to SIP. SIP is an application layer software piece. Didn't say application. And so we're going to take that information from the PSTN signaling, translate it, gateway it to signaling on SIP, and send it back down the stack. That translation is why in the trunk account you have to tell it what type of trunk interface this is. Okay. The steps are pretty straightforward. The write-up questions, when you get to them, and I have not included them in the lab, they'll always be a separate piece. The write-up questions are going to get at what the process is here. What happens if I want to add, if one PRI across this link is not enough? I need more capacity across here. Do I need to create another trunk group? What would I do? If I'm going to use the same, trunk group, I would buy another PRI and just create another physical interface and another trunk account and add that to the same trunk group. I've increased capacity. I don't have to reprogram my accept rules. Okay? Okay. The lab, if if the world ran perfectly, the lab would be posted by tomorrow morning. The world being far less than a perfect place, it'll probably be tomorrow before the lab's posted. Wednesday, I'm not going to expect you to have it. It'd be a good time to ask questions. So if you have a chance to do it for Wednesday, that's great. I haven't thought completely through the timeline on that. I'll probably make the lab itself due by the time we meet Friday, and then the write-up will be due next week on it. Okay? We'll see you Wednesday.